Hello, this is Mr. Collier, and today we're solving equations with a graphing display calculator, the HB prime GDC to be more specific. Alright, so we're going to be solving this equation. Now, it's a very simple linear equation, but there are many equations that are impossible to solve without methods like this. So I just typed it in. So you go to apps, function, and you type in the left-hand side into F1 and the right-hand side into F2. In this case, to tell us what window to use, sometimes you have to figure that yourself. But the y values from negative 10 to 20, and the x values from negative 10 to 30. So to do that precisely, we can go to Shift and then Plot to set up our axes. So for the x window, we can do negative 10 and 30. And y is also negative 10 and 20, and we'll get exactly the correct picture for this. Okay, so we click plot, and this is what it looks like. They're both lines. 15 is the horizontal line because it's just a constant 15. And to get the point of intersection, we simply go to Menu, Function, the intersection, and click here. And well, that's 8.67. It's actually 8 2/3 exactly. Yeah, anyway, that's the point of intersection. So let's draw the sketch where we get a horizontal line at 15. The other one looks like I guess it's not so important. Now, when you're doing the sketch, it's actually the point of intersection is the most important point. So let's not, we don't have to be super accurate with the rest of it. Okay, the point of intersection is what we're interested in, because if you want to solve this equation, we can just get it from the graph. So let's actually solve it manually because it's pretty easy to solve. We multiply both sides by 2 and we get 3x plus 4 equals 30. Subtract 4. And x equals 26 over 3, which is 8 2/3, which matches the x value here, right? The x value is the solution to this equation. So again, this is a pretty simple equation. We don't need to solve it with a calculator, but as the equations get more and more difficult, a calculator becomes very handy. And we can solve equations like this, for instance, which are not so easy to solve. Okay, bacterial growth. Bacteria grows exponentially, so that's why we have an exponential here. If you solve this equation, this determines the number of hours it takes for the bacteria to reach this level, or 200,000. Okay, so we can do the same procedure as before. We can go to apps, function, type in the left-hand side and the right-hand side. So we're going to have 200,000. And that one, and the right side is going to be 300 times 2 to the power of x. X is right here. Alright, and we probably need a different window. With the handheld version, you can pinch and zoom with your fingers. I know I need to go up to 200,000, so I'm going to have to really bump up this y value to more than 200,000, maybe 250,000, so I can actually see the line. That might be okay. X values are what? Number of hours, so I'm guessing no more than 30 might be okay. Maybe I'll go 0 to 30. Let's see what happens when we click plot, and yes, we can see the point of intersection. Otherwise, we have to adjust our window. So we can sketch that real quick. Remember, in this sketch, the most important thing is the point of intersection. So we're going to get that by going to... Now, by the way, sometimes your cursor is really far away. Sometimes it works better if you click really close to the point of intersection. Or sometimes there's more than one intersection, so you have to get the right one and you have to click right near it. And let's click Menu, Function, Intersection, and it gives us this intersection. Yeah, to 3 significant figures, that's 11.0. And, of course, exactly 200,000. But the answer to the question is the t value, which we typed in as x on our calculator. Yeah, it looks like about 11 hours. Okay. So you can go ahead and solve equations like this. If you solve this equation equals this one here, you actually get the point of intersection between these two lines. And when you're solving equations like this, we just type in left-hand side, right-hand side, find the point of intersection, and the x value is a solution. Let's do one more together. This is how compound interest works. So if you have a loan that generates 6.4% interest, then to figure out how much is worth after n years, you have to do the initial amount times 1.064 to the power of the number of years, because every year you're increasing it by 6.4%. So if you solve this equation, you will find out how many years it takes for the investment to double, because that's double the amount of money. So let's do that one. Let's check it out. 3,000. And the other one, let's delete the whole thing. There's a bit of a typo there. That should be 1.064. 1,500 times 1.064 to the power of x. Okay. Now we're going to plot. I need to change my window, I guess. The y values is the amount of money, and we need to see 3,000, so I'm going to go up to 4,000. That should be okay. Plot, and then we can see the point of intersection. With these exponentials, you always get the same curve, really, and that's a constant, so that you get a horizontal. And we can figure out the number of days or number of years by going to intersection. And that's 11.2, and 3,000, of course. Okay, how many years? So you can say 11.2 years. You wouldn't round it down to 11 because it takes more than 11 years. Maybe you could say 12 years of your investment. You can only take it out at the end of a year, but might as well just call it 11.2 years.